So two examples. The first example we're going to do is an expanding one. So you can see there's a lot going on in here, and at first it might look a little intimidating, but let's see if we can break it down and make it a little bit simpler. So what we're going to do is we've got log base 3 of this whole thing. First thing we're going to do is we're going to recognize that when you have the fourth root, okay, so we're working from the outside in. When you have the fourth root, that's really like saying this is the 1/4 power. Okay, so I'm just going to get rid of this radical and I'm going to think of it as a fractional exponent. So when you have a power, okay, you can use the power rule for logs and you can bring that down in front of the log. So this can be written as 1/4 log base 3 of x minus 1 cubed, okay, times x plus 1 to the 1/2 power. So I'm changing this square root to a fractional exponent, a rational exponent, all divided by 5x. Okay, so you're with me so far? The next thing I'm going to do is I'm going to recognize that when you're multiplying, you can write it as a sum of logs, and when you're dividing, you can write it as a difference of logs. So what we're going to do is we're going to continue on with this expansion. We've got 1/4 times the log base 3 of x minus 1 cubed plus the log base 3 x plus 1 to the 1/2 power minus the log base 3 of 5x. Now I did minus because when you divide, you subtract, okay? And then remember, when you have this power here, you can bring it down in front of the log as a coefficient, okay? So we're going to do that. Okay, so I'm just going to write this as 3 here, and I'm going to write this as 1/2 here, okay? All right, with me so far? Okay, then what we're going to do is I'm going to distribute the 1/4, okay, into the bracket here, okay, into the parentheses. So this is going to be 3/4 log base 3 of x minus 1, okay, plus 1/4 times 1/2 is 1/8 log base 3 of x plus 1, okay, minus 1/4 log base 3 of 5x. And then this 5x, you can expand this further as well. 5 times x, we could think of that as a product. And we could write this as log base 3 of 5, okay, plus, okay, so I'm just going to put parentheses here, plus log base 3 of x. And then go ahead and distribute the 1/4 in here, the negative 1/4. So this would be negative 1/4 log base 3 of 5 minus 1/4 log base 3 of x, okay? And we can bring these other terms down. So 1/8 log base 3 x plus 1 and 3/4 log base 3 x minus 1. Okay, so there you go. That's your final expansion. Now, if you want to check your work, and just for practice, what you might want to do is take all of this here and go ahead and condense it. You should get back this original problem that we started with there. Okay, so that's expanding. That was a tough one, but notice what I did is I started from the outside and I worked my way in. Okay, if I have radicals, okay, I converted them into rational or fractional exponents, however you want to say that. And then I used the product and quotient rules. Product you add, quotient you is dividing, but you would subtract the logs. Okay, so let's look at this next example here. Here we have this expanded, okay, logarithmic expression. We want to condense it all down into one logarithm. So how do we do that? Well, okay, what we're going to do is we're basically going to do what we did here in reverse. Okay, first thing I'm going to do is I'm going to bring up all the coefficients as exponents. So if I see a coefficient, I'm just going to bring it up as a power here. Okay, so I'm just bringing those up. Okay. Okay, like that. So in our first step, what we're going to do is we're going to write this as natural log of 2 cubed, which is 8, okay, minus natural log of the square root of 5x, because the 1/2 power is the square root, okay, plus the natural log of the cube root of 7, because the 1/3 power is the cube root, okay, minus the natural log of x, okay, plus the natural log of 2x all to the 4th power, which is 16x to the 4th, minus natural log of x minus 1. Okay, so we took care of the coefficients. We brought those up as powers using the power rule for logs. But now what we want to do is we want to look at everything that's subtracted, okay? When you subtract logs, that's going to be the same as when you divide them. So it's the quotient rule. When you subtract, you divide. When you add, you multiply. So what happens here is anything that's added is going to be in the numerator multiplied together. Those arguments are going to be multiplied. Anything that's subtracted is going to be divided. It's going to go in the denominator, and those arguments are going to be multiplied together. So we're going to condense this all into one natural log here. So follow me on this. We've got natural log of 8, okay, times the cube root of 7, okay, times 16 x to the 4th. So those are all the positive logs, the ones that were added, divided by, okay, the ones we're subtracting, which is the square root of 5x, okay, x, and x minus 1. Now I would continue to simplify this down a little bit more. 8 times 16 is 80 plus 48 is 128. So we have the natural log of 128, x to the 4th, cube root of 7, all divided by, the natural log is not going to be divided, okay, just the argument, okay, so that's a common mistake students make. X times x minus 1 times the square root of 5x. So this is fully condensed, and if you want to check yourself or just practice, I would take this quantity and then go ahead and expand it and see if you get back the original expression there. So I hope this more challenging example helps you to understand logs better. Go ahead and subscribe to the channel if you're enjoying these videos and you're benefiting, okay? And I'll look forward to seeing the future videos. Check out some of my other past videos on logs if you want additional help, and I'll see you in the next video. I'll talk to you soon.